Well, good morning, everyone, and thanks for joining us for our first Azure Kentico virtual conference. This is Tom Robbins with Kentico, and it's really my pleasure to welcome everyone to today's first session. And we do hope that you guys will continue to go through. We have got a pretty full day, a total of 7 sessions, which is really designed to take you from the basics of I don't know anything about the cloud up until I really want to know how to develop on it, and then an opportunity to ask questions around Kentico, CMS, and Windows Azure. It's a pretty exciting day, and we're really happy to see the registration of people who are willing to spend the day with us. As always, we are going to try to record this and make it available afterwards. So if you're not familiar with the agenda, we have it actually showing here. If you would like to register for additional sessions, or you went ahead and you would like to go ahead and register on your own, please let us know and we can go ahead and get you the link. Our first session this morning is by Vince Mayfield, who is the CEO of BitWizards. And we figured that we would start with a very thorough grounding of what is cloud computing in Windows Azure. And these are our two incredibly important topics. And Vince, if you're not familiar, is an expert in this area. BitWizards has been doing a ton of stuff around the cloud. They are one of the Microsoft preferred partners on Windows Azure. But I guess that's enough because we probably want to hear from Vince himself. So without further discussion by me, Vince, how about if I turn it over to you and you go ahead and get going on your overview of Windows Azure?
Excellent, Tom. Can everybody hear me okay?
I think we can.
All right. Well, great. Well, listen, thank you, everybody, for coming today and hearing us present. There's a lot of great content here for you today, and thank you, Tom, for that warm introduction. Again, we're going to be talking and doing an overview here of Windows Azure and Kentico. So, like all presentations, I like to begin with a little bit of background here. So again, at BitWizards, we're a Microsoft Managed Gold Partner, and we are also a Kentico Gold Partner. Been working with Kentico and Azure, Kentico since 2006, and Azure for about 2.5, almost 3 years now. And we're part of Microsoft's Azure Circle program. And I love technology demos because as developers, we all like to kind of come in, and there's always somebody asking us to do a demo, so I always like to show this little Dilbert cartoon. And so at the end of this presentation today, I hope you're going to be saying, I got to get me some of that Kentico and I got to get me some of that Windows Azure. Just a little housekeeping note here. I am in Orlando, Florida at this time, and I'm on vacation with my family, so I'm visiting down at the Mouse House. And so I'm in a hotel room broadcasting to you. And so hopefully we won't have any interruptions, but if we do, if you'll bear with me, and your patience and understanding is appreciated. So let's kind of talk about what is the cloud. So we're going to jump in right here, and if we look at the cloud, it's had an evolutionary meaning. And in the 1960s, we had John McCarthy, who said that computing may someday be organized as a public utility. Now, for those of you that have been involved in computers, you remember that initially that when you were designing applications, when we represented a class using the Booch method, it was represented as a cloud. And then later on, the cloud was also a metaphor for the telephone network. And then finally, a computer network, and lastly, the internet. So when we talk about this cloud, what does it mean? And that's really the problem, is because everybody's throwing that term around all over the place, the cloud. And today when we talk about cloud computing, there's a lot of meanings. And there's, first of all, when we look at cloud computing, there's widespread adoption of virtualization and service-oriented architectures. And when we talk about the cloud, what we really mean is that the details are abstracted from the end user, that there's no need for expertise or control over the technology or infrastructure that supports it. In the end, what we're talking about is that we've commoditized computing, and it's utility-based computing. So the cloud, in my opinion, is the transformation of computer software, hardware, networks into a utility, just like your electric company, your water company, or your gas company. So when we define the cloud here, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. So some of the characteristics that we have when we talk about the cloud is that they are on-demand. Resources should be always available when you need them, and you should have control over turning them on or off to ensure that there's no lack of resource or wastage happening. Another characteristic of cloud computing is that it's scalable. You should be able to scale, which means increase or decrease your capacity when necessary. Cloud providers would have sufficient capacity to meet any needs. The next one would be multi-tenant. Sometimes you may be sharing the same resources, either hardware or with another tenant, but of course it's transparent to the customer. The cloud provider is usually responsible for the security aspect, ensuring that one's tenant won't be able to access another's data. That's a critical point here. A lot of people, and we'll talk a little bit about it, are worried about the cloud because they're worried, hey, somebody's going to have access to my data. And we're going to talk about that more in detail. People feel a little bit more comfortable with it. Another aspect is that cloud computing should be self-service, related to the processes that include billing, resource provisioning, and deployment should be self-service and automated, involving much less manual processing than what you would normally do. So right now, if you're using, when you go down to the IT department and you say, hey, we need to get a new server put in place, and we need to get Windows Server put and installed on it, you basically have to go down and tell somebody you got to put a work order in order to get that done. But when you go into cloud computing, you basically, if you have an automated cloud system, you'd be able to go in and say, hey, I want to turn this on. You basically press a button and make it happen, and your server and your operating system are all provisioned for you. Needs to be reliable. You should be able to provide reliability in the service and committing to uptimes. That means that you want to have an SLA in place. And then the last part is that it's utility-based subscription. You pay the cloud provider as a utility-based subscription, just like paying your electric bill without any upfront investment. So if you think about that when we talk about your utility bill, when I go to turn on a lamp inside my house, I don't have to call the electric company and say, hey, electric company, please add some more power there so that my lamp will come on. You simply turn it on. And that's what we're talking about when we go to cloud-based computing. The other concept there is that when we talk about utility-based computing is that I'm paying for what I use. So when I turn that lamp on, and it starts to provide power to me, that power is metered, and I pay for that power based upon the usage. When I turn that lamp off, then I no longer have to pay for that service anymore. So some terminology that we want to talk about, and I'm going to go into the service models in more detail here in the future. We've got basically the concept of, when we define the cloud, of infrastructure as a service, or IaaS, platform as a service, or PaaS, or software as a service, which is software as a service, or SaaS. And then when we talk about clouds, there's three different types of deployment models. There's a private cloud, there's a public cloud, and a hybrid cloud. Now in the public cloud, the provider refers to the cloud platform that targets any type of customer, regardless of whether they're an independent consumer or if they're an enterprise or even a public sector entity. Normally, public cloud providers are considered prominent players which have invested a huge amount of capital. Windows Azure by Microsoft is one of those cloud platforms, those public cloud platforms. A private cloud is usually an infrastructure that's hosted internally or maybe even at a data center targeting a specific set of customers, and it's sometimes exclusively within an organization. Setting up a private cloud is normally more affordable when compared to a public cloud. Setting up a private cloud is not normally more affordable when as compared to a public cloud, and many organizations actually implement a lot of their own private cloud systems. And then the third option is a hybrid cloud, which is the combination of a public and private cloud, sometimes called on-premise services and cloud services. So in that scenario, what we might have Windows servers running locally, and they're connected to in our own private cloud, and then they're connected to, say, a public cloud like Windows Azure. So we can utilize on-premise and off-premise assets, or in our private cloud assets and our public cloud assets, and have them work together. So why the cloud? So I'm sure a lot of you have heard of the Windows or the Gartner hype cycle. So in the Gartner hype cycle, each year Gartner makes a prediction about what types of things are going to be transformational. And I want to take you back, and if you look at 2011, I mean, the cloud's been around for a while, and Gartner predicted that the most transformational technologies included in the hype cycle are going to be the following: virtualization, big data, cloud advertising, cloud computing, platform as a service, public cloud computing, and hybrid computing. Now, I mentioned that from years ago because I want to say that a lot of people think that the cloud is something that's new. Well, it is, but it's actually been around for a little while, and I want to say that the cloud is here and now. And what I want to mention to that is that when we talk about the cloud, that not only Amazon and Google and the other cloud vendors, but just to kind of give you an idea, Microsoft annually invests approximately $9 billion in R&D. And as of 2012, 95% of Microsoft's 40,000 engineers were working on new cloud applications and new cloud services. And so why is that important? Well, technology leaders like Microsoft don't invest this heavily in technology that is fad or has no real chance of succeeding. And I want to say that the cloud is fast changing the landscape of information technology and how businesses view and utilize resources. On the previous slide, we were talking about the different types of deployment models, and companies are now currently evaluating what types of things do we need to do. Do we have on-premise assets in our private cloud, or do we have assets that reside in the public cloud? So some of the benefits of the cloud, the top 5 advantages of cloud computing are that you pay only for what you use. The second one is easy and fast deployment to end users. The third, monthly payments. So basically I'm paying for what I use and I'm getting billed on a monthly basis. How does that changes things when we talk about our businesses? So when we talk about monthly payments, we're now changing things over from what we call capital expenditures, where we're going out and buying computers, hardware, and we're switching them over to operational expenditures, where we're doing monthly payments. Cloud computing encourages the use of standard systems, and it requires less in-house staff and cost. Some of the top objections to the cloud. And every time we go in and we talk with folks about the cloud, there are three things that I always hear. The first one is compliance issues. And don't get me wrong, it's not that compliance issues aren't valid. The key is that you've got to go take a look at your the trust factor of that particular cloud provider. Take a look at what standards do they adhere to, and then go and apply them to the to your scenario to see if you can meet your compliance issues. Not simply dismiss it out of context. The other one is security. And I've been to the Windows Azure data center, and also I formerly was in the military. And if you take a look at the security that is in the cloud, especially at Microsoft's data centers, and compare that to what I see in on-prem often, as you go down the hallway, you can look down, you can see the administrator's screen up and the password machine there, or you see a closet where people have their servers at. We're talking about world-class security. And then the last part is control. Well, when you talk about the cloud and you're looking at being able to utilize cloud services, most of the cloud vendors give you access and control of your data, of your servers. So what's the real issue here when we're talking about the cloud? And so the real issue is that people don't understand. They have a fear of something that's different or something that's changed. There's a perceived risk because we've lost control and because there is change. And then there's this other thing here where people feel like they need to own stuff. So if I go into a data center that we built and you see all those servers in there and I can actually touch that and it's tangible, inherently in humans, we feel like, we have to own that stuff. So some of the business benefits of the cloud. Reduce cost, and that's something that everybody's trying to do now. We're making do with less, especially in a global recession. People want flexibility, and that is something else that the cloud provides, the ability to have assets on-prem or off-prem or offload workloads that I may not want to have to take care of. I want to be able to expand up. I want to be elastic, and I also want to be able to shrink down. And that's an important part because, when you go out and you buy on-premise assets, you go out and you buy servers and you buy hardware and routers. Well, I have to buy for a capacity that I think I might have now and in the future. And so I may overbuy. In fact, if you go out and you look often, you're going to find that a lot of computers sit around and they're not actually being used probably 20% of the time. The rest of the time they're sitting idle. And so in the cloud, one of the flexibilities is like a rubber band. It allows me to scale up or scale down as I need my computing capacity. It gives me agility and it gives me more mobility. The other thing is that the cloud is highly automated. It's easy to implement, and it helps with end-user productivity. So when we talk about this, you're going to be able to achieve these benefits by having an infrastructure that's usage-based. I can go into my own portal and I can scale up or scale down as needed. It's elastic, and that it's efficient. So what's Microsoft's view of the cloud when we talk about the cloud? Are there any questions at this point? Now I have Brian on board there.
Yeah, no
Sorry,
questions.
Vince. Go ahead,
No,
Tom.
yeah, no questions that we're seeing. I did have one question earlier. Maybe you could. What do you see as an evolution of IT in relation to the different cloud models you talked about? That was a question we had earlier.
Well, to be honest, when Microsoft, and I'm going to talk from Microsoft's perspective. When Microsoft came out, they came out with platform as a service. And we're going to go into that a little more detail later. But I think in terms of cloud computing, that's probably your purest form. And it's your purest form because it totally abstracts you away from the hardware. However, the reality is there's a lot of folks that have a huge investment in software that they've already built. And so one of the things that Microsoft went back to do is add in infrastructure as a service. And so infrastructure as a service is basically virtual machines running in the cloud, but they have, what it's allowed us to do is, or what I think is going to happen with cloud computing is that we're going to have a mixture of assets. We're going to have assets that reside both on-prem and in the cloud. I think that hybrid is going to be the way to go. So when Azure first came out, everybody thought PaaS, PaaS, PaaS. And that meant that we were going to deploy our apps under platform as a service, and we were going to get rid of all of our on-premise assets. Well, that's not really, that's not reality. And so, Microsoft went back and added in infrastructure as a service, which was also already being offered by other cloud providers, but they took it a step further. They took it a step further in allowing the ability to be able to move effectively assets from on-prem to off-prem and then back on-prem again using Microsoft System Center and using Intune and Windows Server 2012, and then also Windows Azure. So what do I see? I see a hybrid cloud scenario in the future. From a Kentico perspective, you're going to be able to choose whether or not you want to deploy into platform as a service in the cloud, or whether you want to use IaaS and deploy like you normally would deploy onto Windows Server, and then utilize those assets either in the cloud or on-prem as needed.
Excellent. Well, I think that answered the question that we had. Vince, go right ahead.
Okay. So what's Microsoft's view of the cloud? So when we talk about Windows Azure, when Microsoft talks about the cloud, they talk about an approach to computing that's about internet scale and connecting to a variety of different devices and endpoints. Now, one of the things that's happened is we've got billions of connected devices, and Microsoft realizes that that can't be a vendor-specific implementation. So one of the things that they've done with their cloud is to make their cloud open, to allow you to connect to a variety of different devices and to basically utilize the data center to scale across the internet. A lot of people talk about scale. They throw a couple servers together and they talk about, and they throw a network load balancer in front of it, and they call that scale. But what we're talking about here is we're talking about a truly global infrastructure, an infrastructure that spans the globe and allows us to basically scale up to maximum amounts of resources and compute power and storage. So let's talk about some of the scenarios in the cloud computing. So these are some cloud computing patterns that would make sense. So the first one is unpredictable bursting. So unpredictable bursting, what you typically had to do was, and what I mean by that would be, you might have an unexpected or unplanned peak in demand. So let's say I'm an e-commerce store and all of a sudden the Wall Street Journal writes something about your organization, and everybody all of a sudden rushes to your website to go buy your product. Well, typically what's happened in the past when we've had those types of things is it's brought the servers and the entire network down. But with cloud computing, Remember what I said is you have elasticity, so you can immediately scale up. So as demand hits the servers and the network load balancer realizes this, or the Windows Azure fabric, it can actually scale up automatically, adding additional servers to handle that load so that your website doesn't go down. So what would really happen in this scenario today, if we weren't using cloud computing, we would have to estimate what we think we might have for capacity. We would have to buy our capacity in terms of servers and operating system and pay for that, and have all those servers maintained and patched and in place, waiting for the time when we might have this unpredictable burst. The next one would be, in terms of cloud computing patterns, is predictable bursting. And so a great example of predictable bursting might be if you had, say, an insurance company, and every month they need to run their financials and they need to run their actuary data at the end of the month. So we asked for predictable bursting, where every month we need more computing capacity. I worked at a company that every month used to have HP roll in with a semi-truck, roll those servers off the truck, plug into the systems, and then run into the month processing, and then unplug those computers, roll them back out into the semi once it was done, and that was usually for a week, and then take them away. And it was a very cost-intensive operation. But with Windows Azure, we can turn around and we can say, hey, I want to scale up each month. I want to add 10 more servers into capacity and then turn them off when I'm done. Maybe they only run for 3 or 4 hours. Or maybe I don't need 10. Maybe I need 100 servers. So I can set it up so that I can handle these predictable bursts. Two more patterns that we'll talk about, and the first one is on and off. So on and off workloads are kind of like maybe a batch job that you might want to run, or maybe, let's say, a social media campaign. A great example of that would be Outback Steakhouse wanted to give away a free bloomin' onion to every person that liked them on Facebook. So they went out, they went to IT, and they said, hey, IT, we're going to need this, we're going to do this Facebook campaign. And IT said, well, how much capacity do you think you're going to need? So everybody got together and they talked about it, and they said, well, we're going to have to buy 4 more Windows servers. We're going to put them into the load balancer. We've got to buy those servers. We've got to add to our CapEx budget. We've got to get them all put in place. And Outback said, there's got to be a better way. So they went to Microsoft and they talked to Microsoft, and this was at the beginning of Windows Azure. And so they built a PaaS-based application to handle the Facebook Blooming Onion campaign. And they paid somebody to develop the application, and they developed it just like they normally do with .NET, minus a few little changes in how they do their, how they call the framework. And they put this into place, and the total cost was about $2,800 for it to run for 3 months. Now, if they'd gone out and bought servers, you know, you were looking at a 15 to 20K capital expenditure or more, not to mention the number of FTEs it would take to go and do it. So cloud computing is perfect for on-again, off-again type of campaigns. The next one is growing fast. So, and I think this is a great pattern, especially for startups. So a company decides that they're going to build a web-based application and offer it as a software as a service application. And you can deploy that, and maybe you deploy it in a high availability scenario where you've got 2 front-end web servers and a back-end database server, and then it can scale as you're growing. So as you grow, you simply go into the portal and say, add more servers. I need more database storage. I need more local storage. And it allows you to scale with agility. So the 3 key cloud computing terms here are IaaS, or infrastructure as a service, where it's a host PaaS, where you're focused on building, or platform as a service, or SaaS, software as a service. And that's where you simply consume. So from Microsoft's perspective, on the Microsoft platform, you have applications, you have the application platform, and you have the data center and the desktop. And they don't really care whether you have the assets on-premise or in the cloud. From their perspective, it's exactly the same. So when we look at how Microsoft views the cloud a little bit further, when we break this down, when you've got your choices between running on-prem or off-prem, when you talk about management, when we're talking about on-premise, you got to manage it yourself. Your infrastructure is heterogeneous. You got to think about your business model in terms of capital expenditure, and you own it. But when you look over off-premise, or you're looking at the cloud, it's a homogeneous environment, and you're looking at things from operational expenditure. In this case, you're leasing or renting, or you're doing utility-based computing, and you basically have a third party running it. Across the top, it really doesn't matter because the application programming interface is exactly the same. You have multi-tenancy, automated service management, high availability. So what is Windows Azure? So let's talk about the cloud computing taxonomy. So when we look at when we talked about infrastructure as a service, when you normally look at applications and you normally look at traditional IT, you're looking at traditional packaged software, you're responsible to manage everything. So you're basically managing everything in here. You're responsible for the networking. You're responsible for the application, the data, the runtime, the middleware, the servers, and you're also responsible for every bit of the core cost to maintain that infrastructure. When we talk about infrastructure as a service, things are abstracted a little bit better, and in that case, you usually use virtualization, and what's managed by the vendor is this part here, the virtualization, the servers, and the storage. But you're still responsible for the OS, the middleware, the runtime, and the data. When we talk about platform as a service, what's managed by the vendor, oops, not very good in my drawing here, is the runtime, the middleware, the OS, the virtualization, the servers, the storage, and the networking. And in that case, you only have to worry about what's important to you, which is your application and in your data. The last part is software as a service. And in the software as a service, everything is managed by the vendor. Now you have decreased flexibility, but the lowest cost. The problem is that you may want to be able to enhance or tie in, and you're limited by only what the vendor allows you to do. So in terms of flexibility, you've got more flexibility when you have packaged software. And as you move across the spectrum here, you've got less flexibility in terms of what you're able to do, but you're sacrificing that in a model where you've got decreased cost and decreased total cost of ownership. Higher cost, more control to the left, lower cost and higher agility to the right. From Microsoft's perspective, what's the most important part of all of this is it's the application stupid. And I take that from the old Raging Cajun when he was talking about that during the election. You know, he said it was the economy stupid, but at the core, for Microsoft, it's the application that's the most important part of this. So we have when you talk to business owners and you ask them, did they get into business to own a bunch of IT assets? The answer is no. What's important is the business functionality that is provided by the application or solves a business problem. So Azure, in a nutshell, what we're talking about is a comprehensive set of services that enable you to manage, build, and deploy and manage applications across a globally managed Microsoft, a global network of Microsoft managed data centers. The three tenets of that are that it is flexible, it's open, and it's solid. It's a global footprint. It's a footprint in terms of data and infrastructure that runs across the entire world. And it has, backed by a service level agreement of 99.95 monthly SLA. Now, that SLA varies by the different types of services, and that can be found if you go up to the Microsoft Trust Center website, and it will talk about what specific services, but in general, Azure as a whole has a 99.95 monthly SLA. Just to give you an example, people will ask and they'll say, you know, do cloud architectures fail? And yes, sometimes they do. And but Microsoft financially backs that. And a great example of this was last year when there was a cloud failure. They not only came back and told everybody, and they're very transparent, they came back and they told everybody everything that went wrong in a public blog, why it went wrong, and what were the steps they did to fix it. And then on top of that, they went back and they refunded everybody for the month their usage, even though they were only out for a few hours. In this case, you pay only for what you use. So when you've got a computer and it's sitting there idle, or you've got an instance and it's sitting there idle, then you don't pay for it. So just kind of a little bit of an overview of Windows Azure from the architecture details. At the top level, you have your application and your data, and then you have the platform. And a great way to understand this is to understand that you have an infrastructure and an app fabric controller. And the great way to think of the fabric is like the central nervous system of the body. And what it does is it's out there, it's constantly looking at all the compute instances and all the storage instances. And then you have the app fabric controller, which is the brain. And what it does is it senses when there's problems and does automatic failover. So a couple things that have happened over the last couple years, like typically happens when a Microsoft rolls out a technology, they kind of change around the terminology a little bit. And so what it boils down to is that there are three main components, and there are in Windows Azure three main components when it talks about hosting your applications: virtual machines, cloud services, and websites. And if the best way to kind of equate these around is virtual machines is centered around IaaS, or infrastructure as a service, and cloud services and websites are centered around PaaS, or platform as a service. So one of the big things about virtual machines, and I told you that Microsoft has an open platform, it's that it supports both Windows Server and Linux. You can install any software you want in the virtual machine because the virtual machine belongs to you. So you can actually set up your virtual machine on-prem and then push it up and deploy it into the cloud, or you can go through the self-service portal and spin it up and configure it how you want it. You can also set up virtual private network to connect your VMs to your on-premise infrastructure. So you could actually physically, say, maybe have a SQL server that's on premise, and you could push data up to your virtual machine into the cloud via a virtual private network. There's a few aspects of Windows Azure that I want to talk a little bit more about, and it's the ability to have virtual machine portability between Windows Azure and different environments. All the virtual machines that are running in Windows Azure are using the format called the VHD format. And VHD is an open specification that's been released by Microsoft. Microsoft uses VHDs in a variety of other products, including Windows Server virtualization. Hence, that will allow that ability to transfer between on-prem and off-prem virtual machine instances. Some of the benefits of using that same file format is it's really easy to open that file format. The benefit is that since Microsoft is using an open file format, they have the ability to take the VM from your own data centers and upload it into the Windows Azure data center. You don't have to run it an import or an export process. You simply upload it and it works. There's no conversion tools or agent that you have to install in the VM. It simply works. The other thing that this offers is that it not only allows you to run Windows Azure as a data center itself, but also allows you to run other service in other service providers as well. So you can basically take the VMs from any of these locations and move them into another data center. This means that there's no vendor lock-in. So you've got a lot of flexibility of portability and ensures that you have no lock-in in terms of the vendor. The other thing that's really neat that they're doing with Windows Azure is that it's making it possible for you to mount durable drives in your virtual machines. And they're doing it in a way that's very reliable and consistent, and it delivers high performance. One of the things that's different about how Microsoft enabled it is that when you mount a drive, either in the portal or in the command line, they're backing up the disk with the Windows Azure storage system so that they're running in the cloud right now. And there's a couple of nice characteristics about the storage system. The first one is replication. So when I go and upload, when you upload a VHD, what happens in the cloud is Microsoft takes that one VHD and it replicates 2 additional copies so that you have a backup. So they have triple replication with the content within the data center. If the disk ever goes bad, that your data is on, then there are 2 other copies of that data that can be worked with, and we don't have any interruption of service. They can simply spin up a new replica once they detect the disk is bad. From your virtual machines perspective, you never know that there's an issue that actually occurred. So as you can see there, when you copy that virtual machine up there, it automatically made 3 copies. And then when the fabric detects that there's a problem, it simply shuts down that particular VHD and it makes another copy, so you always have a redundant copy. So the VMs with the persistent drive, they're reliable and they're always on. So another thing that's nice about Windows Azure storage solution is that they have support for continuous storage replication across geographies. So if I want to replicate and have data exist or have our VMs exist or storage exist in multiple geolocations, I can do that, or I can have it reside in a single data center. Why would you might want to have it reside in a single data center? Well, one reason you might want to do that is maybe your local laws in your country don't allow you to have data outside of your region. And so for those reasons, you can specify in your portal where you want it to be. However, if you want continuous or continuous storage and georeplication, it's built in by default. What that means is whenever you save something in the storage system, in the background, Microsoft automatically replicates that data to another data center. And they guarantee that these data centers are even though those data centers are miles apart, in the case of a natural disaster or a complete data center failure, you can ensure that a copy of your data exists somewhere else. Give you an example, when I was at the Microsoft data center in Chicago, they talked about when Hurricane Sandy hit the East Coast. One of the things that they did was they moved all of their the VMs and data out of their existing data center and moved it over into other data centers away from where the hurricane was happening, and then they moved them back over after all was clear. So if that data center had been wiped out, your data, your VMs, your computing cycles have all been preserved and moved to another location. The end result is that you can deliver a more robust solution with greater integrity. So virtual machine capabilities are one of the great features that are part of Windows Azure. The next one I want to talk about is Windows Azure websites. Now, for those of you out there that are familiar with Kentico, everybody, and I'm sure there's a lot of folks out there that are agencies or that deal with other things. Real quick here, before we move forward, are there any other questions at this point? Tom, Brian?
Hey Vince, this is Brian. Yeah, this is Brian. We did get a question in as to if you could explain how would you kind of recommend for a company that maybe already had a bunch of virtual machines but is looking to move to Azure, what would you kind of say to them as a good starting point or a way to kind of get their feet wet in that environment?
Well, one way to get your feet wet is to identify some workloads that are maybe not critical or business critical that you would like to try. And I would simply set up a trial account and move some of them over and take a look at them and test them in that environment. And then once you feel comfortable with it, then I would switch them over. Now, obviously, if you're using VMware, there are some additional steps that have to be taken to move them out of the VMware format. But if you're already running Hyper-V and VHDs, then you can simply move those over from on-prem to off-prem. If you haven't yet virtualized, you can obviously virtualize one. But I would start basically with something that was of that was low-hanging fruit, and go and test it out. I mean, not everybody's going to jump into the cloud right away, and not everybody's going to jump in, with both feet. So start with some assets that are going to provide some business value to you. Anything else? Any other questions?
No, that's it for now.
Okay, so Windows Azure websites. So you can build so when we talk about Windows Azure websites, don't confuse this terminology with your website. We're just talking about what I would call a workload. It could be a website, and it could be a Kentico website. But basically what you're doing is you're going to build an application, or you're going to run Kentico, which runs on ASP.NET, but it can also support Node.js or PHP. And you deploy it in within seconds via FTP, Git, or TFS. And you start out, and it's free, and then you scale up as your traffic goes. So basically, Windows Azure websites, there is a managed service that you can use to run websites and the web API. And you don't have to really worry about or think about VMs, servers, or infrastructure. So this is why I mentioned earlier that this is kind of an extension of PaaS. You can simply focus on building and deploying an HTTP-based application. It enables you to build your sites using ASP.NET, Node.js, or PHP. It allows you to use any tool and any operating system to build these sites, including Windows, OS X, or Linux. And then you can easily deploy these sites using the tools and infrastructure that you know. Now, Microsoft supports several flexible deployment models, including FTP, Git, and TFS. And what's nice about this offering is that it not only does it enable to get you up and running very quickly, but it also allows you to start with a free offer in a shared environment. And you can then scale up the sites using reserved instances for higher performance and isolation, and scale out these sites as your website becomes more successful and you have increased load. So when you first pull into Windows Azure for websites, you go and you deploy your app into Windows Azure for websites, and it's into a shared virtual server, and you're running your application with multiple other tenants running on that specific virtual server. Now, your data is isolated, nobody has access to it, but you are running in a multi-tenant environment. You can actually scale up to two shared instances, so that you have network load balance traffic to your two sites. The next level is you can go and you can say, I want to move them out of the shared instances as your site grows, and I want to move it into a reserved instance by itself, where you're not in a multi-tenant environment. So you're basically on your own virtual machine. You're not sharing that virtual machine. And you can scale up as necessary to go to two reserved instances, and you have direct control over those specific instances and what they do. That takes us to our next level. So we've talked about virtual machines and we've talked about websites. Let's talk about cloud services. And cloud services is really PaaS, and it's if you look back on this, take away virtual machines, take away websites, this is the original platform as a service that Microsoft released. So cloud services is another model that Microsoft's been has worked on for building applications, and enables you to build what is sometimes referred to as infinitely scalable applications. You remember I told you before that under IaaS, you still have some control over the hardware and the OS. When you move over into cloud services, you're abstracted to your application and your data. And this is the PaaS model. Since these are infinitely scalable, they can support 1 to hundreds or even thousands of computers or compute instances. It supports not only web-based developments, but also supports multi-tiered architectures where you might have a combination of front ends, middle tiers, as well as virtual machines running as a part of your solution. So you're not sacrificing any kind of flexibility like what you have over in IaaS. So just like you could build out an infrastructure in IaaS, and you could set up 2 web front ends, and you could have 2 middle tier data layers or data access layers, and then you could have your data layers. You can do this over in cloud services. It's just different in how you architect the solution. This supports automated application management, so it's real easy to deploy and scale out, isolate, and recover from any type of a hardware failure, as well as support for automated updates. So let's spend a few minutes talking about what happens when you deploy a service to Windows Azure. So you're in Visual Studio, and you're going to build a service package. So when you deploy that service package to Windows Azure, what happens is you provision a role instance, and you deploy the application code. What happens behind the scenes is that Windows Azure takes that package, takes the service definition that's built into it, and decides and spins up for you a number of virtual machines that are necessary to support your app. So it's important to note here that in Windows Azure, to achieve the 99.95 SLA, you have to deploy to at least 2 instances. Once you deploy your package, it goes up, and Windows Azure spins up your virtual instances for you. It takes those, and then it actually places them into play at the Windows Azure Data Center. Then, behind the scenes, the App Fabric, which is basically a network load balancer, allows multiple devices to come in and utilize and spread your load across the number of virtual machines that you have or a number of Azure instances that you have spun up. If, while it's running, the Fabric determines that you have an instance that's not performing correctly, what it will do is it will turn off that specific instance, spin up a new instance, cloning your existing instance, and then factor it back into the network load balancer, all without you having to do anything. By the same token, if you came in, you could come into your portal and you could say, hey, we've got more capacity that we need. You could say spin up 5 more additional instances, and you could put that in as well. Or you could scale back down from 4 instances to 2 instances. I think you can see here the flexibility that's in place. So in addition to that, in addition to the 3 core things that are built into Windows Azure, the virtual machines, the websites, and the compute, one thing that we've done with one thing that's been done with Windows Azure is that they've provided a bunch of application building blocks. So in addition to the 3 things that we talked about before, cloud computing, virtual, and websites, there's also support in there for big data, for databases, formerly called SQL Azure, now just SQL databases, storage, networking and traffic management. There's also caching services. There's messaging services, so you can interconnect data applications across between each other. There's identity services, allowing you to connect identity between on-prem and off-prem assets. There's media services, content delivery network, and of course networking. These are all managed services that Microsoft runs that provide a lot of value, so you can avoid standing up infrastructure for some of these common capabilities. You can always stand up VMs and put anything you want into it, but in a lot of cases you're going to find that Microsoft has built services that they can deploy faster than you might be able to do if you had to stand up the VMs and deliver them yourself. What's cool is that you can use any of these services with a VM, you can use them with a website instance, or you can use them with cloud services. So you have flexibility in how you consume these different building block services. A couple of the key ones that I want to talk about is I want to talk about SQL database, because everybody knows that we store data and that relational database and relational data is important. So at the core, the SQL database is the same relational SQL Server engine that you expect on premises, but is available in the cloud. It's clustered for high availability, and it's a fully managed service, and it also supports SQL reporting services. So let's look at what that looks like here. So when we talk about SQL databases, what you automatically get here is some high availability clustering. So what happens is that initially you have your single database, and what Windows Azure does behind the scenes, or SQL database does, is it basically sets up 3 additional copies, which are basically multiple physical replications of that data. And what happens is that when you reads are always done at the primary, and then writes are replicated to a quorum of secondaries. So in the case of when you write data from your application to a single database instance, what happens is you write first that database instance, and then what happens is behind the scenes, it's replicated to 3 other different databases. So you have multiple redundancy there. Now, what happens is let's say that one of those instances, your single primary, starts to act up. So what Windows Azure will automatically do behind the scenes, or SQL database, is that it will point you to one of the replicas immediately, and then what it will do is go ahead and make that the single primary, and then it will turn around and replicate another set over here, so that you always have 3 redundant copies. At the core, it's the same tools, same data access frameworks, and the same T-SQL-based languages that you've used in the past. Difference is you get that high availability cluster of databases that maybe you might not be able to afford or have typically on-prem. So some ideas, or not ideas, but some kind of a comparison between SQL databases versus SQL Azure. On SQL databases, when you talk about SQL Azure, or I'm sorry, SQL databases is now SQL Azure, apologize, terminology there, versus SQL Server. So when we talk about SQL databases, or SQL databases in the cloud, we're talking about horizontal scaling as opposed to vertical scaling. Now, what does that mean? Well, typically, when you wanted to add more space to a SQL server, you simply add more SAN storage or disk storage out there, and you could spin up infinitely as large as you want to get. But because we're using a multi-tenant model, and we have to be able to guarantee that high availability and redundancy, there's a limit of 150 gigabytes to a database, a SQL database. So what does that mean? Does that mean that we shouldn't we think that we might infinitely scale up beyond 150 gigabytes? And possibility is yes. Well, what we've got to do is we design differently. So what we may do is partition our databases out into multiple databases, keeping it down below 150 gigabytes. Not all T-SQL commands are supported. There's no SSIS, although they're adding in new features that will allow things like that. You can only use SQL Server authentication. You don't have any access to the system tables, but you can control it using SQL Server Management Studio, on-prem and off-prem assets. And it doesn't support database mirroring or failover clustering. Right. So in summary, Windows Azure provides you a comprehensive set of services that you can selectively compose to build your cloud apps. Again, it's a 99.95% monthly SLA, and you pay only for what you use. It's a flexible open computing options, when you can choose between virtual machines, websites, or cloud services. And then there's a managed building blocks of services like SQL Database, Cache, Service Bus, and more. In the end, I would just say that Windows Azure is an economic discussion. It's not necessarily a technical discussion. The reasons to go to the cloud are often economic. And I think one of the things that Windows Azure provides is it provides the power of instant infrastructure. I can simply go into my portal and I can turn it on whenever I want. And I'm getting close on time here. I just want to quickly run through to kind of talk to you quickly about the Azure data centers. So there's 6 data centers across 3 continents. You've got the North Central, the South Central, the North Europe, the West Europe, East Asia, and Southeast Asia. And then there are actually some additional data centers now that have been built, or supplementary data centers in the United States. There's 2 on the East Coast and 2 on the West Coast. There's also the CDN, the Content Delivery Network, which has over 2 terabytes per second of capacity over 22 global locations, and it allows, and there are more that are coming on board, which allows us to scale global reach with caching and with the content delivery across the world. And just to kind of give you an idea of what the Azure data centers look like inside, there are these modular IT packs, or modular components, and inside of these are rows and rows of 2,400 separate computers. And then running on those computers are the virtual machines, or the Azure instances. Basically, they'll come in and they'll lower these down on the floor. They provision them all within 8 hours, plug them into electric and cooling capacity, and then they bring them into the Azure Fabric. And then from that, the Fabric controller controls what goes on from there. Give you an idea, I talked to you before about that some of these machines, as they start to have problems, they simply shut them off. And then when these IT packs, when say 67% or more of them aren't working, they simply take the whole thing offline. They transfer the workloads before they take it offline over to other IT packs, and then they refurbish the entire thing. This is inside of what the containers look like. And that's it. Does anybody have any questions?
Thanks, Vince. I know we're a few minutes over. If anyone has any questions, please go ahead and send them in. See, we'll wait. So, Vince, if someone wanted to get in touch with you for more information, what would be the easiest way to do that?
They could go to our website, www.bitwizards.com. I'll pull that slide up here. Actually, I don't have that slide.
That's right.
Basically, you can go to our website, www.bitwizards.com, or you can reach out to me at vince@bitwizards.com, and either one of those ways.
All right. Well, I'm not seeing any questions come in. Let's see. We got one question, actually a more general. Webinars are being recorded. Yes, we're trying to record everything today, and assuming there's no major technical issues, we'll make those available on our DevNet site. Just, I guess, a quick one, Vince, and then we probably want to end. We had one question. If you have multiple database instances, an instance in the U.S. and one in Asia, how would the sync or replication work?
Well, the sync...
Vince, I was going to say, I was going to cover that in my advanced development, but go ahead and answer as well, Vince, if you want to. But I was going to cover a little bit of that in my session as well.
No, I'll let Brian cover that there. But basically, I'll say at this point, you don't really have to worry about the sync or the replication. It's automatically done for you. As I showed on the one slide there, when you write to a single database, it automatically writes in quorum to the other databases that are there.
Okay, great.
And then there are some other options as well.
Okay. All right. Well, I appreciate everyone joining us. I know that we're a little bit over, and I want to thank Vince for a great presentation. Hopefully, you're going to join us again in about another 15 minutes or so as we move on to Get Set, an introduction to Windows Azure development presented by Brian McKeever. Who's not only a Kentico MVP, but he's also from Kentico Gold Partner at BizStream. So with that, Vince, thanks very much for joining, and we will rejoin everyone on our next session on the Azure Kentico Virtual Conference in about 15 to 20 minutes. Thanks, everyone. Talk to you shortly.